take your hands down. Thank you. Okay, so next up we have Julien, so round of applause for him. Thank you very much.
Thanks. So, good morning. My name is Julien. I'm a Go developer. I work at Continuous. Continuous is a company behind an open source project named Traffic. And Traffic is an open source reverse proxy made to deploy microservices with ears. What does it mean? It means that Traffic doesn't need any configuration file. Traffic just connect to your orchestrator API and then refresh its configuration dynamically by listening to your orchestrator event, by listening to your new container, your new service. So today for me, it makes sense to talk to you how to write a reverse proxy. When I start to work on a presentation, I usually search for the main word of my talk on Wikipedia, because everybody knows that Wikipedia is the real truth. And so, if we search for reverse proxy on Wikipedia, we can find something like this. A reverse proxy is a type of proxy server that will retrieve resources on behalf of a client from one or more servers. And then these resources are then returned to the client as if they originated from the web server itself. So, if we highlight the main word of this definition, we can say that a reverse proxy is a proxy server that will return resources from servers to client. So, in this live coding session, we will need a server, we will need a client, and we will code a proxy server that will return resources. So, the first thing, the server. I think that today, the simple way to have a server is just to launch a Docker container. So, we will use a Docker container. I prepare a container to show you all the use case. So, thank you. I will run this container. Okay. Thank you. And so next, we will need a client. For the client, I could have used a browser, but I think a browser is not enough to show you all the use case. So I will use the curl command. So let's try to call this server with the curl command. So I will just use the curl command and say I want to call my server. No, HTTP. Oh. Oh, this is difficult. Okay, here I call my server. And then the next step is to build a proxy server. So for this, we will need an empty main function, and we will use the HTTP package and the listen and serve function, and we will listen on the port 8080, and that's all. We have a server. I launch, and then let's try now on this server. Okay, we have a page not found because we need to return resources. So let's try to return resources. We need the demo URL. We will use the IP of our container. Oh, sorry. Okay, and I will just handle the error. Okay, and I will use the HTTP util new single host reverse proxy with this demo URL, and I will put this into my server. Let's try now. No, I need to restart. Okay, let's start, and it works. Thank you. Do you have any question? Oh, yes. I did not use the 25 minutes. Sorry. We need to deep dive, but I think it's interesting to know that this implementation exists. This implementation is maintained by the Go team. This is improved too. For example, in the next version, the 1.12, they add the support of WebSocket. So with the 1.12 version, you can proxify some WebSocket server, but we will need to deep dive. So what we have is this. We have a client that just sends a request to our reverse proxy. What we will need is to forward the request to our server. So let's do this. So we will remove this thing. Okay, we will use a new handler, and we will just take the request, modify the host with our demo host. We will need to modify the URL host too with the demo URL host 2. We will need to change the scheme to. Okay. And we need to remove the request tree on the request because the request tree is filled by the server. And a client will reject a request with a request tree. So we need to empty it. Okay. And now we will use the default HTTP client to just forward this request. I will handle the error because we are in a live coding session, and if I have errors, I want to know what happened. So here we will just write an internal server error. Okay, and we will just write in the body the error. Okay, and we will return. Okay, I will just ignore this for the moment. I restore it, and then if I try to call my reverse proxy, you can see that my demo container receives a request. Okay, but I still have no content because I need to copy the response. So we will copy the response just by write the status code. So, okay, and then we will copy just the body of the response. We restart, and then, if we try now, we have our content. Okay, now let's try another pass. I have a demo.json, and you can see that this is a JSON, but the content type is wrong, no? What about my demo server? Oh yeah, this is a good content type, so I missed something. In fact, we need to copy response header too. We only copy the status code and the body. So let's copy the response header too. So for this, we will just, before writing the status code, we will loop on the header of the response. The headers are map of string, so we need to have a double loop, and we will just set this on our response. Okay, let's restart and try again. Oh. Here I have my content type. Good. Next use case. XForwardedFor. What is XForwardedFor? Imagine if I take my client and I just call my demo server. The demo server will receive a request with a remote address ended by 3. This is my IP. This is a client IP. But if I use the reverse proxy, in fact, the reverse proxy will call the demo server. So the reverse proxy will receive a remote address with a 3, but the demo server will receive an address with a 1. So I can't know what is the client IP. So for this, we need XForwardedFor. Let's see it in a real life. So I will try to run curl in a container to have a new IP. And if I call directly my demo server, you can see that the remote address is with a 3. Now, if I try to call my reverse proxy, you can see that this is a 1. So I will set the XForwardedFor header. So the only thing we have to do for this is just on the request, we will set the header XForwardedFor with the remote address value. But in fact, the remote address is not enough because the remote address contains a port. So we need to split on the port and just keep the host. Okay, let's try again. Now, if I call my reverse proxy, I have a XForwardedFor with the IP with a 3. Okay. Next use case. Stream. What is stream? Stream is when your server starts to send the body, then flush, and then send more body. Let's see it in a real case. If I use curl to call my demo server. I can see that. I have the beginning of the body, then I wait, and I have the end. Okay? Let's try this on our reverse proxy now. Okay, we wait, and we have all. So, why? This is because we only flush at the end of the handler. So, to handle this, we will need to flush more. For this, what we can do is just start a new go routine that will just loop with a ticker. For example, a ticker of something like 10 milliseconds. And I will just flush. I'm really sorry for your harm. Okay, and in order not to have some go routine leak, I will just use a new chain to stop this go routine when the body finish the copy. Okay. So just a case with the done, and we will return the go routine, and then we will just close this chain here. Okay, now let's try this. I restart, and I try again. Okay, now we have stream on our reverse proxy. Next use case, trailer. You know what is trailer? Trailer is like header, but that will coming soon. So, as you may know, headers can be sent only before you write the status code. And if you want to send something after, you need to do this like this. So, you start to announce trailer. You will say what you will fill next or during the body, and then you write your status code, you write your body, and you can start to set the trailer value. What happened in the raw body? In fact, the body will be in chunk, and the chunk is a chunk size, then a chunk content, then a chunk size, a chunk content, and if your chunk size is 0, this is a trailer. So this will be something like this. We have 5 bytes, the hello, the content, then 0 byte, and the X trailer value. Let's see it in a real case. So if I called my demo, you can see that I have the trailer here. I announce that I will have X trailer, and then I fill the X trailer with the X value. Let's try this on our reverse proxy. It doesn't work, because we need to announce our trailer, and we need to send the trailer after the body was read. Because in the client port, we need to read the trailer before to read the body. We will only have the keys, and then we read the body, and we will have the value. So we will handle that in our reverse proxy. So just before to write the header, we will just create a trailer keys slice. Then we will loop on the trailer in the response. And here we only have the key, in fact. So we will just append the key in the trailer key. And then we will announce the trailer by just write a header named trailer with the trailer keys value joined just by a comma. Okay, let's try with this. Now, as you can see, we announce the trailer. We have the header trailer with X trailer, but we don't have any value. So we will need to fill the value. For this, we'll do something like for the header, but after reading the body, because we need to fill the trailer, and so we will loop on the trailer. Trailer is a map of slice of string 2, so we need to use the value, a double loop on the values, okay, and we just set our value. And this will fill our trailer. Let's try with this. Okay, the X trailer value is here. Next thing, HTTP2. So You're a Go developer, you know that HTTP2 needs HTTPS. No, it's wrong. In fact, HTTP2 needs knowledge. What does it mean? It means that if you know that your server can do HTTP2, you can do HTTP2. For example, the gRPC server is just HTTP2 and the client is HTTP2. You don't need HTTPS. But if you don't know, the simple way to know this is to use TLS LPM. How it works? In fact, when you will do the TLS LPM, you will send the client hello with the protocol you support. The client will say, I can do HTTP1, I can do HTTP2, and then the server will just choose which protocol to use. And it will return this in the server hello, in the selected protocol. So if we want our reverse proxy to do some HTTP2, we need to be in HTTPS. Let's do this. We will just change our listen and serve to be a listen and serve TLS, and we will add set file and key file. Okay, and now if I restore it, my reverse proxy is in HTTPS. And I already know that my demo server just can't do HTTPS, so I will just change the scheme here. Okay, so it could be enough, but the default client in Go doesn't say that it supports HTTP2. You need to configure the transport of your client to just say, I can do HTTP2. And in order to do this, you need to use the HTTP2 package and the configure transport function and just give your transport. So we will give the default transport as we use the default client, and we need to just type it. Okay, and with this, I will use HTTP2. Let's try this. If you can see here, this is HTTP2. Oh no, bad request, why? Hey, yes, I need to do HTTPS, you know. Okay, and now this is HTTP2. And do you know what use HTTP2 and trailer? Because maybe you think you never use trailer or you never use HTTP2, but gRPC use HTTP2 and trailer. So if you want a reverse proxy that can do gRPC, you need to implement HTTP2 and trailer. Okay. We could have here lots of other things, but the time goes, and so now this is a real end, and you can ask for questions. Thank you.
Any questions, raise your hand, please. Yeah.
I was wondering about the TLS version you talked about with 4 letters. Can you talk a bit more about it and explain it? The A something?
ALPM. What is ALPM?
ELPN is really the protocol negotiation. So this is really the part that will negotiate which protocol you will use after the end check, in fact.
No.
This was really clear.
Okay, so if there's no more questions, round of applause for Julien.